previous video, we learned about the definition of the compilation system. From this video, we will talk about the more detailed information of each component of compilation system. As you know, we can connect the Linux server with our own ID and password, but sometimes you cannot disconnect. You cannot connect to the Linux server with your own ID and password because of the overload of the many students at a time, or server manager the resurveyed or check the status of the server. So at that time, if you have some problem of the disconnection, please wait 1 or 2 hours, and then you can reconnect with your own ID and password. All right. For example, at this time, even though I also try to the Linux server with my putty, as you can see on the screen, the host name swin.skku.edu, port number, the establishment of the 성균관 University. So 1398 port. And then even though I want to connect the Linux our university server, but I think server manager check the status and the trace of the server. So today is the Sunday weekend, so sometimes we cannot connect and we can't meet the network error, connection timeout. But I successfully connected yesterday, so that means server manager have some trouble or checking of the server status. All right, so I will try to connect our university server after 1 or 2 hours or tomorrow. Okay, so please understand the server the disconnection sometimes because of many students and professors shared our 성균관 University Linux server. All right, so don't worry about it. Regardless of the server connection or disconnection, please listen and watch, take a look our video clip well, and then you can try to connect again after some time. All right, so today we will talk about what happened to our Hello program when we learn it. All right, so as you can see on the screen, there is the terminal snapshot, and if we try to put the execution commands, the current directory with the execution file name, and after enter, we can check the successful result, hello, word. So I mentioned number 1, input, and number 2, search, number 3 is print. So if you compare each comment with the below figure, when we input the current directory and execution file with the enter, computer, specifically the shell program, try to find the execution file on our own disk. All right, so please compare number 1 with this below figure number 1. All right, so if you put the /hello with your own keywords, shell program try to find the hello execution file name on your own disk. All right, so hello executable stored on your own disk. Okay, in a previous video we successfully made our own hello.c file, right? So our own disk have the hello.c, and if we successfully compiled our hello.c file, we also have the execution hello file on your own disk, alright? So shell program computer try to your own hello execution store the file on your disk. And then if the shell found the hello execution stored file on your disk, and then it can print the proper results with your own monitor, alright? Similar to the hello, word, alright? So please memorize 3 steps: input, search, print, alright? So after executing proper command, shell program wait next to your own command, similar to this, the blanket. Okay? Okay, we can go to the next page. So, even though we cannot open our own desktop, but some students already the build or the fix your own desktop with your own home desktop and so on, alright? So if you open your own desktop, there are so many hardware components such as the CPU, the memory chip, mainboard, cooler, disk, and so on. Of course, the graphic card, right? So some students were interested in your own game, right? So in this case, mainboard and graphic card should be very higher the capacity or the ability than others, right? So it is up to you the capability or the system architecture based on your interest, right? But if you consider the normal, the common desktop, they have the most similar the component design with the this screen, all right? So when you look at the CPU is the abbreviation Central Processing Unit, similar to our brain, right? So the CPU can calculate with the arithmetic operation units, and CPU can cooperate with the memory for the executable the commands with the memory address and so on. And the PC is the abbreviation of the program counter. So we will talk about the detailed information maybe in chapter 5 and 6, so don't worry about it, all right? Still, we learned about chapter 1, even though we learned the chapter 1 slowly, but don't worry about it because chapter 1 can cover all process over our lecture, and chapter 1 have the main part of the each chapter from chapter 1 to the chapter 11 and so on, all right? So don't worry about the steps of our the lecture, okay? And of course, we can also learn about the inputs and outputs concept, similar to the keyboard and the monitor, all right? So we already type the executable file or compilation, the command, right? So user type the hello or the executable file name, all right? So the shell computer can search the executable file in your own disk, as I mentioned, all right? Of course, if you want to consider network concept from our computer to the other friends or the internet-based other desktop, we should extend the I/O bus to the other computers. So we can learn about the socket programming in chapter 11 or 12 and so on. So based on our steps of our lecture, with the students' the degree, we can also touch the socket programming, network programming a little, okay? So don't worry about it, okay? So in step 1, we can type, and as I mentioned, you can check the borderline, okay? We can find the executable file on your disk, all right? And then when you check the another board lines in step 3, we can check the proper result in our monitor, okay? But when you check the borderline again, even though we only put the executable file name with our keywords, the keyword cooperate with the I/O bridge as well as the CPU partial part as well as the main memory, all right? And disk, the searching part can also cooperate with disk controller, I/O bridge, main memory. So all components of this screen are hardware, right? So the hardware can be cooperated with the software concept, such as the executable file or shell program, all right? And lastly, in step 3, the display can be possible based on the CPU, bus interface, I/O bridge, as well as main memory, on top of the graphics adapter, all right? So monitor can display proper the result, okay? So we will talk about the more detailed definition of each hardware component. Please take a picture of these slides, and you can also write down each definition in your own notes. So you should trace, you can put your own writing in your own note, okay? And then you can take a picture your own writing as well as this slide, and then you can paste in your own Word file. You don't need to submit your Word file per a week. You can also, not also, but only submit your own Word file whenever I request in iCampus, all right? So don't worry about your the Word portfolio submission every week, okay? Most important thing, your understanding and your the sincere study of the computer structure. So please write down each definition many times in your notes comfortably, and then you can take a picture, the necessary slides page, and then periodically check your cell phone for yourself, and then naturally memorize the English definition of each component, and you should try to memorize and understand sincerely for yourself, all right? So what is the main memory? Have you ever heard about the main memory? Right, you have heard many times main memory regardless of our lecture, right? In fact, main memory is a temporary storage device. So it holds both program and data it manipulates while the processor is executing the program. And main memory is a dynamic random access memory. So abbreviation is DRAM, okay? So when you check the capital of each word, D, R, A, M, right? So main memory is temporary storage device, and the abbreviation is DRAM, all right? So even though we made hello.c, whenever we took a look the lecture video, our own hello.c and executable file of the main memory can be disappeared, all right? But if you save your own hello.c in your local desktop or laptop, the hello.c can be stored your own disk, all right? But when we consider the executable, the step real time, our own executable file or data can be temporarily stored in main memory for efficient operation with the CPU cooperation, all right? So the main memory is a temporary storage device, okay? And abbreviation is DRAM, okay? Dynamic Random Access Memory. Okay, so we will learn the information in chapter 6, so don't worry about it, okay? And what is buses? Buses is a collection of electrical conduit. So that is the real line, not wireless. The bus is the wired line. So we can deliver the electrical concept, okay? So when you open your own desktop, we can check the many kinds of wired buses, all right? So it can carry bytes of information back and forth between the components, back and forth, all right? And it can transfer fixed size chunk of the bytes known as words, such as 32 bits or 64 bits. Most of our operation system supports the 64 bits these days, right? So that means buses can deliver or transfer the fixed size chunk of the bytes known as 64 bits, all right? So naturally we can recognize, oh, the 64 bits, the operation system based desktop can be faster than 32 bits, all right? So if you want to install the necessary programs on your 64 bits, we should select the 64 bits supportable program, application program, such as the PuTTY or KakaoTalk or Microsoft, the official, and so on, all right? So most these days, the desktop or laptop can support 64 bits, all right? Okay, so we can check or learn these concepts both in the chapter 6 and chapter 10, okay? So we can learn them soon, okay? Okay. And we can also check the TMA concept too. That is the abbreviation of the direct memory access. Okay. Okay, please take a picture, this slide too, for your own the understanding. So what is the abbreviation? The central processing unit, that is CPU. So CPU and central processing unit and processor are same words, all right? So processor, CPU, central processing units are same, All right? Similar words, synonym. Not synonym, but same. Okay? So CPU is the engine that interprets or executes instructions stored in main memory. All right? So we can execute our hello.c with the executable file name hello. All right? So the executable file name hello is the instruction or instruction. So if we type current directory with the executable file name in shell, CPU can't execute or interpret our instruction stored in main memory. Okay? So when you take a look, CPU, there are PC, register file, and arithmetic logic unit. So please focus on the red box. Okay? So please close your eyes and memorize all by yourself. CPU is composed of PC, register file, and ALU. All right. Please memorize at least three components of a CPU. All right. And please quit my video and write down each definition and this figure in your own note and take a picture and paste to your own Word portfolio file, okay, for yourself. And please memorize each definition as well as the rough figure of the CPU, the buses, main memory, as well as disk. All right. So what is PC? PC is the program counter. So it is a word-size storage device. Storage device. It is also storage device, but it is not big, right? But a word-size storage device. So PC is another name is register. Okay, and it can contain the address of main memory. It only contains the address of main memory, not data, but the address. So what is difference between data and the address? Data is the big size, right? But address is the address of the space of the stored data, right? So address is the more smaller information of the original data, right? So that is related with pointer concept of the C programming language, and it is very difficult part of the C programming language than other grammar part, but it is the merit of the C program than other interpreting languages such as the Python and R, because when you imagine the address manipulation with the C programming language, we can control our own data very quickly in the raw level, right? So we can speed up the execution of our code, and we can control our own data manipulation very efficiently, all right? So don't worry about the address concept of the C programming on top of the Linux. We can cover in pointer part of the C programming with enough time in future, all right? So don't worry about it. The main point is PC is the small size device, storage device, and it can only contain the address of main memory, okay? And what is the register file? It is also a small storage device, a collection of word-sized registers, right? So register files is the collection of the word-sized registers. What is the ALU? ALU can compute new data and address values. All right. So what is arithmetic? arithmetic operations such as addition, subtraction, multiplication, division, right? So similar to the brain, the CPU, specifically ALU, can compute new data with the operation, arithmetic operation, with the address values concept. All right. So please take a look and memorize and write down these concepts many times on your own note. Okay. All right. So we will talk about simple operations of CPU in this slide. So we can divide by 4 steps of the CPU. First is load. Second is store. Third is operate. First is jump. Okay. So what is load? CPU can copy a byte or word from main memory into register, overriding the previous contents of register. Store is the copy of the bytes or word from a register to a location in main memory, overriding the previous contents of that location. Okay, so loads and store are different concepts. All right, and what is the operation? Operation is the copy of the contents of 2 registers to the ALU. Perform an arithmetic operation on the 2 words and store the result in a register, overriding the previous contents of that register. Okay? So operation is related with the ALU concept. Okay? And what is jump? Jump is the extraction of the word from the instruction itself and copy that word into the PC, overriding the previous value of the PC. So we can lawfully can check the operation of the CPU with the 4 steps. All right. So load, store, operate, jump. Okay. So when you check the 5 steps of with the same figure of the previous slide, if you type with your own keywords, first CPU check the proper instruction in main memory. If CPU found the proper instruction in main memory, it can cooperate with the PC and ALU for quick and efficient the computation, right? But still, if CPU did not find the proper instruction properly in main memory only, CPU can operate with the I/O buses with the disk controller for checking the existence or the helpful information in disk. So in 3 steps, the disk can be related with for the result. And then main memory can finally solve the proper instruction with the CPU. After that, the monitor can display, all right, the proper result for the user or programmer, all right? So we can understand the main memory is a tentative device for the proper result, all right? But the stored file, such as hello.c, as well as executable file, the stored in local disk forever. All right. So that is the main point of our lecture. Okay. In this video, we talk about the simple operation of the CPU as well as the more specific operation of the executable file on your own disk. All right. From next video, we will talk about the definition of the caches. All right. So please memorize each definition of the main memory and the simple operation of the CPU and the proper each component of the CPU such as PC, register file, ILU. And please write down your own understanding and the main information of each slide componently freely on your note and take a look and paste the files to your own portfolio file. All right. Someday, I request your own portfolio Word file, the assignment menu of the iCampus of our lecture. Maybe next week or the next week, next week, you can upload your own trace of your own study as well as my request based on my lecture video, and I will check your the diligence and your understanding status and your the understanding part or the short part, and I can recommend or advise the proper parts for on each student. Okay, thank you for listening. See you next video. Bye bye.